Please welcome to the stage Dr. Jenann Ismael, Professor of Philosophy at Johns Hopkins University.
So sometimes the deepest and most profound truths are not on the frontiers of knowledge, but staring us right in the face. So suppose we want to program a computer to be our grand overarching database or repository of information about everything. So we set about programming it with as much factual information as we can about the world. We program it with the laws of physics and all of the scientific knowledge that we've amassed, facts about the history of the Earth, the vast reaches of space and time, the monkeys of Costa Rica. And the goal is to be able to put to any question of physical fact in an input channel, and the answer will appear on an output channel. Okay. Seems like there should be no barrier to such a thing. But it's actually not hard to find a question that it can't answer truthfully. So we just ask it, is the answer that's about to be displayed in the output channel no? So if you think about this for a second, you'll see that it can't answer truthfully. No matter what answer it gives, giving the answer, it will be doing the opposite of what it is saying. So if it says yes, what it says is false. If it says no, what it says is false. Okay. Now this kind of thing is familiar to computer scientists, logicians, and readers of XKCD. The problem is that the answer is referring to itself, so what the system is doing in giving the answer contradicts what it's saying. Self-reference is a known source of paradox. It introduces, and because it introduces, the most famous example, of course, is this sentence is false. And because it introduces contradictions into any logical system, mathematicians, logicians, and certainly computer scientists know that we want to steer as clear of self-reference as we can. Okay. Surprising thing is that there's no way to avoid self-reference if what we're trying to do is construct the sort of database that we were talking about above. And that forces the recognition of something that's obvious as soon as it is said, which is that there's no way to avoid self-reference if we're representing the world that we are part of. Okay? Doesn't matter how much we know about the laws of physics, how powerful our computers are, how sneaky we are about asking questions or what language we use, we are always going to be able to find questions like, is the answer that's about to appear on the screen no? That is to say, questions that we can't answer truthfully without contradicting what we say. And what that means is that there's no hope of having a complete and accurate representation of the world. So it might seem that this is a minor thing or easy to get around, but it turns out that once self-reference is there, it can affect everything. And it's harder to quarantine the problem than you might think. Generations of the very smartest mathematicians have struggled to get around the havoc that Gödel wrought with a version of this problem in mathematics. So big gestalt-shifting insights don't come from turning away from things that we don't understand, but from leaning into them. Until now, Until now, self-reference has mostly stayed out of physics. So one is usually modeling other systems, so cells, gases, pendula, or planets. And in that setting, one maintains a provisional separation of subject and object, or of investigator and system being investigated. Cosmology is the one science where it's the physics of totality, so the universe as a whole, all of space and time, and you might have expected that self-reference would become explicit in that setting, but it's customary in cosmology to kind of imagine that we're looking at the universe from outside. So you've all seen this image of the standard model of cosmology, and you might have thought that you were looking at an image of the universe in the way that you might look at, for example, an image of a planet as seen from a long distance. But that's a profoundly misleading way of interpreting this image. This is meant to be a representation of all of space and time. So one of the spatial dimensions is suppressed. One of them is kind of implicit in the oval at the end, but this dimension along the bottom is meant to represent time. So looking at the image, as you're doing now, you're cast in the fictional vantage point outside of space and time. In actual fact, of course, there is no vantage point outside of space and time. This view from outside the universe is a complete mirage. We are part of the universe. Anything we do happens in space and time, and any attempt that we make to describe the universe implicitly involves self-reference. So physics worked very well for a long time by maintaining this imaginative fiction that we're looking at the universe from the outside, but there are all kinds of signs now that the fiction is breaking down. The problem that that self-referential question brings out is that by saying things, the computer is also doing things. And when a system is participating in the events that it's representing, there are going to be relationships between what it says or what it's representing and what it's doing by representing, by doing in the representational act. And what we did in the self-referential question was that we exploited that relationship to create a question that the system can't answer without doing the opposite of what it says. But that's just a vivid way of making the point that we are part of the universe, and a correction to the tendency to think about the universe from that transcendent or external point of view. So yesterday morning in the introductory video, if you were here, Zina asked, are we in the world or is the world in us? And the answer is, of course, both. We are in the world because we're part of the world, but it's also in us because we're representing it. So we're creating an internal image of the world. From a physics point of view, all of this is interesting because it introduces a source of instability or unpredictability into the world that has nothing to do with indeterminism and nothing to do with ignorance. And it turns out to be the simplest form of a much more general phenomenon, one that we didn't notice for so long, but only because we were so imaginatively entrenched in that transcendent point of view. We forgot that we're part of the universe, not mere spectators in the events that we're representing, but players on the field. Now, the people that have unavoidably encountered this are people who are, for example, trying to program an artificial general intelligence. So what they want to do is they want to program a system with a bunch of general knowledge and the ability to model the world. And they're confronted by the fact that the system is going to have to model itself and its own activity. And that puts the self-referential structure right at the heart of its knowledge of the world. The same, of course, is true for us. We are centered in the regime of self-reference. As thinking things, we are centered in the regime of self-reference. We aren't just gathering information about the world. That is to say, we're not just gathering information about a world that's there to be known, waiting for us. Okay? We are representing a world that is shaped in real time by our own active engagement. We are, that is to say, making the world as we represent it. Okay? We watch and we predict, and we use our predictions to deter or forestall predictions that we don't like, and encourage or promote predictions that we do, that is to say, to guide the world to a more favored state. And what that means is that our predictions work against themselves in the way that that self-referential question did. That is, we often work to undermine the predictions. They face headwinds of their own creation. Okay? Intelligence of the kind that we have is not just meant to represent the world. It's meant to intervene. It's not just meant to predict. It's meant, in some cases, to counteract predictions. It's embodied and it's action-oriented. It involves information flows and feedback. And that means the living world, the world that we inhabit, is less like physics in its standard form than it is like economics, where prediction is essentially unstable because the domain that we're representing is responding to our predictions and our attempts to predict it. So my recommendation is that, My recommendation is that we shouldn't suppress or ignore self-reference. We should lean into it and we should learn from it. This insight holds the key, I think, to some of the most deepest enigmas of current science, things that the transcendent or external understanding of the world will never get right. So among these, I think, are the right understanding of the nature of time, the regime of life and intelligence, and the next step in AI. Thank you very much.